Hello, how are you? Hi,
Very
everybody.
Are you ready to go?
Yes, I am. May I share my screen?
Please.
Okay, can you see my screen now? Okay.
Yep, go ahead.
Okay, now in presentation mode. So hi, everybody. Thank you for the invitation to join in this workshop. I'm going to talk to you about a project, an initiative that we are involved in and starting to develop for a project in Angola on on fire management and the exploration of carbon opportunities. So it's the goal of the project is to implement sustainable fire management in Angola. It's an ISFMI-led project on emissions reduction, basically trying to replicate in Angola the Australian experience with savanna fire management. Also involved in this project are the United Nations FAO, ourselves, University of Lisbon, and also the Free University of Amsterdam. We are developing a proposal that will be submitted to request funding from the Green Climate Fund of the World Bank. This initiative has already been going on, or the preparation for this initiative has been going on for a while. There have been several meetings involving, namely, people from different ministries in the Angolan government and other relevant institutions. So we now have a national commitment with this initiative. And last summer, boreal summer, there was a field trip to check potential project implementation sites throughout Angola. Unfortunately, I wasn't able to participate in that field trip, but there were members from the Australian team, the Portuguese team, the Dutch team, and so they interacted with local populations, visited different settings, different sites, namely in northern central Angola, in Malange, also in the extreme southeast of Angola at Cuando. And so they did a really good prospecting of potential project implementation sites. Here are we show where they are located, outlined here in red, the different project implementation sites. So in Malange province, Lunda Sul, Muxico, Huila, and Cuando. And they are distributed so that they cover a range of Angolan ecoregions. You see that this larger yellow patch is the Angolan Miombo woodlands. Most of the sites are located in Miombo woodlands. There are also other sites in Baikia woodlands and in the southern Congolian forest savanna mosaic. One of the smaller sites is at the place where three different biome ecoregions meet, and so it's the most diverse of all sites. The fact that, for example, they are in Miombo woodlands ecoregion doesn't necessarily mean that woodlands are the dominant land cover. For example, at Camea here in Mochico, although it's Miombo woodland region, the dominant land cover are grasslands. And here in the southeast at Mavinga, it's a variety of land covers dominated by shrublands, but also with significant areas of woodlands and grasslands. And so when you look at this intersection of ecoregions with actual land cover, these sites cover a wide variety and the most representative situations that are relevant for fire management in Angola. There are some key attributes of Angola fire regimes that make the country really interesting and with very good potential for emissions reduction by managing some key aspects of the fire regime, namely its seasonality, as established by the Australian experience. Angola suffers very extensive savanna burning. It's really a fire hotspot at the global scale. Throughout most of the area, the fires occur very regularly. I mean, interannually, they occur very regularly. Seasonality is very well defined, quite well marked. Burning is shifted towards late in the dry season, and there is evidence of very strong anthropogenic control over the vegetation burning activities. So when you consider these fire regime attributes together, they mean that there is very strong potential for emissions reduction via savanna fire management. Let me show you a bit more about these features I just mentioned. So here we have Angola. We've seen parts of at least southern Angola in previous presentations. On average, 30% of the country's 1,250,000 plus square kilometers burn every year. We developed this map of the mean fraction burned in 5x5 square kilometer cells for the last 20 years. And it's obvious that our sites fall on a range of fire incidence values, ranging from lower fire incidents at Bicuar in Huila and at Mavinga in Cuando Cubango to very heavily burned sites, namely in Malange, in Lunda Sul, Mochico, the grasslands here, and also in the southernmost site of Cuando Cubango. So from that standpoint, the selection of sites is also covering an interesting range of fire incidence level. Burning occurs very regularly, like I have mentioned to you. Here we calculated the coefficient of variation, the interannual coefficient of variation in area burned. So low values, lighter colored values in the map represent very regular burning, so annual burning or close to it. Higher coefficient of variation means more sporadic burning. And so you see that there is a well-defined geography on this variable too. Our areas are more are on the higher regularity of interannual burning. The graph on the left shows an overall view for the country. And so you see that even at national level, the same picture is obvious. with very regular burning, little interannual variability, both in terms of burned area and in terms of active fire. Seasonality is well shown here. 74% of the area burned occurs during the late dry season over the period 2003 to 2019, defining the threshold between the two seasons in the month of June. So April, May, June, early dry season, July, August, September, late dry season. And you see that the burning over all these years is significantly shifted towards the late dry season, 74% versus 26%. I had access to some data that the Australian team collected in Botswana for open woodlands and woodlands very close to the southeastern border of Angola, Botswana. And those data show that in terms of the seasonality, emissions for methane and nitrous oxide are also themselves very, very shifted towards the late dry season. They are about 2.4, 2.5 times higher in the late dry season than in the early dry season. So there's plenty of room to attempt to shift the burning towards earlier in the season, and therefore to reduce the emissions via all the components in the process, namely area burn, combustion completeness, and emissions factors. Another dimension of the fire regime that we looked at is fire intensity, analyzed with the MODIS fire radiative power data. And we see that fire radiative power or fire intensity is indeed lower in the early dry season at most of the sites. Here at the southeasternmost site, there doesn't seem to be much of a difference in fire radiative power between the early and the late dry season. And the northeasternmost site, the Lunda Sul site, has a strange pattern where the fire intensity in the late dry season is slightly lower than in the early dry season. We haven't done any field work related to this, so we do not have an explanation for that unexpected pattern, but very clearly throughout most of the sites, there are quite substantial differences in the way expected with higher fire intensities in the late dry season. Here is an overview of the seasonality by implementation site, by project implementation site. And we see that the one that is most shifted, or the province where the burning is most shifted towards the late dry season, is Mochico here in the eastern central section of the country. But all the other sites, to a greater or lesser extent, specifically the provinces, display that same pattern. Cubango also strongly shifted towards the late dry season. So plenty of room for improvement. We also looked at, we did some data analysis to characterize burned area trends in Angola, again using MODIS data with its known limitations in failing to capture a substantial amount of the smaller burns. But still, we got these patterns with a very patchy arrangement of trends. Green for decreasing burned area trends and red for increasing burned area trends. The way we interpret this patchy look of the map is that these trends are under strong anthropogenic control. Climatic control would have produced smoother patterns. Certainly, I suspect that there will be a climatic fingerprint on these patterns, but I hypothesize that anthropogenic control is strong because of this fine scale pattern. There are some extensive areas of decreasing burned area trends here in southeastern Angola. They appear to be associated with conversion of pastures to forests. And there is a large area of increasing burned area trend. And it appears to be associated with the opposite pattern of land use, land cover change from forest to pasture conversion. We looked at data from HILDA, a land cover, a global land cover land use change project, and it seems to point in this direction, namely here in southern Angola on the edge of one of our sites, but also getting into one of our sites. There is indeed indication of forest gain in blue and pasture loss in red. And here in this central, this area here, the opposite trend, a mixture of gain and loss of forest, but with some substantial loss, and indication of an increase in pasture gain here in blue, and areas with mixed pasture gain and loss. There is also an interesting area, if we go back, this area of strong increasing burned area, which has not yet produced land use, land cover change. We need to look into that to see whether it is more recent or what are the reasons. Although it's outside of our study areas, it may be relevant in understanding lags between increases in fire incidents and conversions of land cover type. And these aspects are relevant because they give us indications on the potential to go just beyond emissions reduction and get into the domain of managing fire to actually accomplish carbon sequestration. In Southern Hemisphere Africa, there are some really long-term experiments on fire exclusion and manipulation of fire frequency. Long-term in these systems means over 10 years in grassland, about over 20 years in savannas. And the indication, not only from these long-term experiments, but also from extensive modeling with dynamical global vegetation models, indicate that climate would support forests in many of these landscapes if fire was excluded. And interesting, it has also been found that fire exclusion in grasslands with mean annual precipitation higher than 650 millimeters, actually really opens up the succession and ends in fire-sensitive forests. In drier areas below this 650 millimeter threshold, fire exclusion has led to increases in tree density and tree size, but not so much in a trend of actual conversion to forest. So there is some climatic limitation on top of the fire-induced limitation. And when fire is removed, the climate constraints still act, and they allow for an increase in woody cover and woody biomass, but not full conversion to forest. I think we think it would be interesting to consider not only or to go beyond the goal of emissions reduction and start exploring these possibilities for more in-depth carbon sequestration. But there are no long-term fire exclusion experiments in Angola, but there is the potential to do it. Recently, at the Biquar site in National Park in Huila, and in the whole province, this one here, local institutions have set up a network of permanent plots to monitor vegetation, not only in floristic terms, but also in quantitative, in biometric terms. And it's a quite extensive network, and it has very good potential to be used in conjunction with analysis of fire frequency and in observational terms to provide information on the impacts of fire frequency, intervals between consecutive fires, number of times burned, all of those relevant temporal fire regime descriptors, and to quantify their impacts on biomass. So using this network of permanent plots already in place. But we think it would be worthwhile exploring the possibilities of interacting with local institutions, namely the herbarium at Lubango, the province capital, and we have a PhD student at the University of Lisbon who is in Darwin currently attending this workshop, José Chamba. He was involved in this project, or he is involved, that has produced this paper describing the first vegetation plot database of woody species for the Huila province in Angola. We would be very interested in exploring opportunities opened up by this project we are working on to strengthen local infrastructure, technical and scientific capability, and if possible, expand the network of vegetation plots for observational assessment of these relationships between fire frequency and carbon sequestration, and ideally to set up long-term fire frequency manipulation, including fire exclusion, an experiment to assess the impacts on sea sequestration in an experimental manner. So we better control over these and better understanding of these relationships. Although it's not the most fire-prone of our implementation sites, Bikwar National Park in Huila has advantages. A key one is having local institutions active in this domain with whom we can interact and who are already doing very interesting and valuable work. But it is from the biogeographical standpoint, the most diverse of all the sites, because 3 ecoregions meet there. I already mentioned this, I think, Zambesian, the Baitia woodlands, the Miombo woodlands, and the Mopani woodlands region all meet here. So it provides a very good sample where we may consider engaging in a more ambitious component of savanna fire management and attempt this incursion into the carbon sequestration domain, and namely with this possibility of having a fire exclusion experiment. So this is what we have been planning for, and we are currently developing a feasibility study. We are in almost finishing our feasibility study that will support that will be one of the key elements for the proposal that FAO and ISFMI will present to the World Bank Green Climate Fund, expecting that we will get funded to develop this project in Angola and add such a key country regionally in terms of savanna fire to this fantastic network that our Australian and African colleagues have been developing throughout Southern Hemisphere Africa over the last half a dozen years, I think maybe a bit more. So that's what I have to present to you. Thank you for your attention. If you have any questions, please let me know.